Ken Forster, Executive Director at Momenta. Welcome to our Digital Thread podcast, produced by, for, and about digital industry leaders. In this series of conversations, we capture insights from the best and brightest minds in digital industry. They're executives, entrepreneurs, advisors, and other thought leaders. What they have in common is, like our team at Momenta, they are deep industry operators. We hope you find these podcasts informative, and as always, we welcome your comments and suggestions. Good day and welcome to episode 186 of our Momenta Digital Thread podcast series. Today I'm pleased to host Nikhil Chauhan, Digital Transformation Officer, Wind River Systems, the leading software for mission-critical intelligence systems. At Wind River, Nikhil leads industrial, energy, and health tech industries globally. He is a business and technology executive with over 25 years of worldwide multifunctional experience. Over his career, he has yielded $4 billion of value, step change digital transformations, strategic pivots to SaaS, cross-platform solutions from over 50 products, unique thought leadership such as defining software-defined machines at GE, scalable operating mechanisms, and top-graded centers of excellence at GE, Hitachi, Cisco, Philips, Teradata, and Ericsson. He holds an MBA from Henley Management College and a Bachelors in Electronics and Telecommunications Engineering. Nikhil, welcome to our Digital Thread podcast.
Ken, thank you for this opportunity. Your podcast is an exceptional learning source from you and the industry's best. I'm very excited to be here.
Oh, and we're very excited to have you. And thank you so much for being clearly an active listener. So having listened so much, we always like to lead with a bit of a provocative question. That is really, what would you consider to be your digital thread? In other words, the one or more thematic threads that define your digital industry journey.
So there are three thematic threads that define my journey. One is the value chain. So I had the opportunity, Ken, to work with various value chain constituents in the public, private, and startup space. And that includes hardware, software, technology enablers, which have been NXP Semiconductors and Wind River Systems, network equipment, infrastructure, and connectivity service providers, Ericsson and Cisco, data analytics products and platforms provider, Teradata, machinery and equipment OEMs who are building solutions and engaging the end business customers. And those have been GE and Hitachi in my case. And then I've worked with system integrators who are enhancing the experiences of end customers, along with startups whom I mentored through the Alchemist Accelerator. The second thread for me is the functional thread. So I started my career as an industry factory production manager. I then migrated to software engineering, which is where I worked at a startup called Systemonic, which got acquired by Philips, eventually became NXP Semiconductors. I did semiconductor product program management, played roles doing general management and strategy, product portfolio solutions management, product solutions marketing, product operations, and then business development, sales, and go-to-market. So far, the career has been thankful, and I think so far I have got a chance to incubate and deliver, launch, and market solutions, platforms, and products. The third thread is the digital transformation thread. So in my experiences, I've contributed to the multi-year digital transformation journey of my employers, but also their customers across the OT and IT. And that spans from understanding the digital maturity, framing the digital challenge for prioritized outcomes, focusing the investment, mobilizing the organization, and then sustaining that transition. So those first two threads of value chain and functional helped me with that third thread. And those diversity of experiences, it helped me to understand the business through a holistic lens. And equipped with that, I do innovate business and technology by answering what is the winning aspiration and strategy, where to play and how to win, both from an offering and a go-to-market perspective, what cross-portfolio capabilities are needed to win, what are the organization's control points, how should capabilities be developed, deployed, and launched and sold to be customer-centric, and what business people, processes, technologies are required to succeed. So those digital threads allowed me to use levers in my roles such as a service business model adaptation or value-based solutions incubation or tech modernization, customer experience reinvention, and data monetization.
It's a very rich experience base, and I love the fact that it feels like a full stack one from both technology leadership to functional application together with business strategy. Probably very fitting since your title is Digital Transformation Officer at Wind River. Perhaps as a level set, how do you define digital transformation?
Yeah. To me, Ken, digital transformation is a mindset. It's a mindset that drives step change and disruption and yields increased profit, productivity, and performance. With the digital transformation mindset, I've seen companies create value through three ways. One is through new frontiers. So, for some enterprises, this may be developing new businesses in adjacent categories. For others, it may be about identifying and going after new value pools in existing sectors through pivoted business models. Second way is to reinvent those end to end customer experiences. And that's really to reimagine how customers are served by injecting audience centricity, rethinking how digital capabilities can be designed and delivered for the best possible experience. And the third is through foundational culture. And that's about the technological and organizational plumbing that allows an enterprise to be agile, data influenced, and more efficient in terms of its underlying processes. Now, here's what I find interesting and important. The leading digital transformers excel in both the what of digital and the how of digital. The what makes these businesses different through, as I said, reinvented business models or top grading experiences or operational processes. But the how is the leadership capability of creating a compelling vision, engaging the organization at scale by being agile and flexible, governing digitally, and integrating those business and technology teams for an efficient operating model.
Now, in between the bookends of your time with Wind River, you've had a really long track record of leading roles from head of edge to cloud and digital at GE or director at GE Digital to leading product marketing at Cisco IoT Cloud BU to head of portfolio at Hitachi Vantara to VP product portfolio management at Teradata to seeding the IoT strategy at Wind River in the early 2010s. And now, of course, as I said, bookending with your digital transformation officer. It's a pretty wide experience base. What did this time teach you about edge computing in industrial?
So let me break the answer by sharing my learnings around the why for industrials, why edge for them, the market dynamics, including what we are seeing right now, as well as some of the digital transformation learnings associated with edge computing in industrial. So the strategic business issues continue to fall under the categories of increasing revenue or market share, increasing efficiencies, productivity, increasing quality, reliability, as well as decreasing cost. The market headwinds that are pressurizing the industrials are, of course, the pandemic, the workforce shortage and the skills gap, and the supply chain bottlenecks. And some of them are turning around and they're getting kind of better now. But those combined with intensifying global competition, increasing hardware commoditization, especially in the industrial manufacturing sector, those are creating a sense of urgency and shifting the value pools from products to software and service. So, the goal for many of these industrials is to disrupt their traditional ways of working, remain competitive, and transform themselves by adopting various digital levers, define and execute strategies that leverage the potential of their people, maximize their control points, and leverage modern technologies to transform operations and, of course, business performance, and create that tangible value by combining the real time customer data with real time performance data of their products to improve the operational performance and efficiency. To address these goals, the industrials are transforming by making some fundamental shifts. They're moving from discrete products to platform based solutions and applications development, from complex and non standard discounting to simplified discounting and ordering, moving from physical to remote provisioning and delivery, from upfront to recurring payment and revenue, from one time transaction models to ongoing sell business models, from issue resolution to customer success, from being process based to knowledge based, from being capital intensive to insight intensive. And from a technology perspective, they're leveraging these tech for creating those new efficiencies, for integrating fragmented assets, massive data volumes, expertise, tools, processes, and technologies. And they're pooling and combining these resources creatively. They're using and reusing them, extracting new synergies, applying them very broadly across not just specific products and product lines, but across businesses, geographies, and across entire solution categories. And by doing so, they are retooling the underlying business processes, which ranges from consumption pricing and billing to demand planning to product dev to customer success. And they're shifting towards these digital industrial business models, which are, again, as I said, being retooled to sell anything as a service. And in my experience, I'm seeing that anything can be as wide as machinery and factory systems like robots to utility systems or wide operational settings like factories, cities, grids, or hospitals, or even societal goals like sustainability. So that's the macro view. In my experience, I then got a chance to understand and define edge for my employers as well as ecosystem so that we can standardize the lexicon as well as some of the investments focus. There are ample definitions on edge and edge computing, so I won't spend your time on speaking about that. But what I understood was this whole edge to cloud distributed continuum, which spans from the endpoints to the near edge to far edge to the cloud. And within that continuum, workloads should run where they make the most sense for the business and technical outcomes. These layers differ in terms of latency, underlying network, which can be OT or IT, hardware software customization, resource constraints, and compute, as well as the way they are developed in terms of pure embedded versus cloud native. Edge computing is obviously complementing the cloud as a deployment model, and I've evangelized that quite a bit in my roles as well, where I understood that cloud-only deployment model has limitations. The connectivity to cloud is limited. There is an assumption that there is optimal connectivity and enough bandwidth to transfer the data. Cloud computing does add latency and centralizes analytics. And cloud obviously is suited for various use cases, including some of the most computationally intensive AI processing tasks, and cloud will continue to grow. But from an edge standpoint, edge deployment addresses some of those limitations of cloud-only model. Of course, there are use cases which need reduced latency for mission control. You need adherence to the SLAs and regulatory compliance. You want to avoid unnecessary data exposure. You want to reduce the reliance on the network connection. So I got a chance then to understand why edge specific to industrial. So edge computing plays an unparalleled role in allowing manufacturers to transform their operational plans towards Industry 4.0 and now 5.0. In the industrial sector, edge computing is highly relevant because it is proven to meet the sector-specific requirements of ultra-low interrupt latency of under 2 microseconds and a jitter of less than 10 microseconds. It works in air-gapped environment, suits the network bandwidth requirements and data economics, data exposure, 6 nines reliability, security, privacy, regulatory compliance, as well as those edge inference requirements specific to worker safety and safety critical operational use cases. As one of my article headlines stated, edge is the door to the industrial IoT data kingdom. We also see that there is an increased proportion of all AI processing that's going to happen at the edge. And if we look at the Flexera's 2022 State of the Cloud report, 18% of their respondents are planning to keep most or all of their IoT edge data on premises. 25% will have a mix of on-prem and in the cloud. And I would expect that these will be higher in the industrial sector because this specific survey had just 4% respondents from the industrial sector. Now, just shifting gears and talking about the voice of industrial customers, which these are the customers who told me about some of those technology needs. So when we look at the industrial operators, they want to connect, they want to harness value from all operating assets at the edge, regardless of the vendor or the vintage. They want to manage complex industrial data by supporting those unique volume, velocity, variety, and veracity requirements. And with the advent of software-defined intelligent systems, industrial manufacturing supply chains are becoming more agile and smart, and they're quickly transforming into autonomous self-learning and interoperable ecosystems. Most industrials are adopting, they're adapting cloud to their needs and they're complementing it with the edge. I then looked at some of those market dynamics and global seismic trends, which tell us that edge is important. After all, the intelligent edge spending is projected to be north of $700 billion dollars by 2028. We know that edge computing is part of the successful tech enablement in the industrial sector that could unlock up to $2 trillion dollars in total return to shareholders. And the machine economy will drive 70% of all GDP growth by 2030. This is the second wave of digital transformation, which is from the IT to the OT. Now, while helping my employers and the customers transform, I found that digital transformation is complex. It takes people, process, tech, and time. It needs 110% commitment, as well as a compelling vision or strategy and execution. So, in my experiences, there are a set of success factors for this transformation journey, and that needs an interlocked strategy with clear transformation goals. You need leadership commitment from the CEO through the middle management. The executive leadership team identifies they need to deploy high caliber talent. You need a digital governance mindset that acts quickly using a unified digital operating model and drives broader adoption. You need effective monitoring of progress towards those defined outcomes. And of course, you need the business led modular technology and data platform. And finally, when tackling these, the executive team needs to make sure that each of these six adequately addressed in their planning, preparation, and execution. And you have a leadership team that complements each other, offers a diversity of viewpoints, but is also very effective in working together.
Now, it's apropos, given your role in terms of leading industrial, energy, and health tech industries globally for Wind River, that you talk about digital transformation. So, given this digital transformation officer title, how do you approach and engage with companies in these sectors on behalf of Wind River?
So, part of my role's charter is to help create customers' transformational business plan and guide them to reimagine their digital transformation journey. During the engagement, we understand the business objectives and business issues, the problems, the solutions and the ideas that can solve the problems, the value and the business case, the people and the key players involved, as well as the execution plan, which are the steps to get through the finish line. So after joining here, I established a repeatable framework based on what has worked for me in the past and in current customer situations. The framework has various touch points such as meetings and workshops and proof of value demonstrations. We document the mutual plans. We define entry-exit criteria of these stages. We focus on the ideal outcomes to establish the vision and then set the expectation around the people and processes. At a high level, the framework has three core phases. We first establish a baseline and the what. So that's understanding the current state in terms of people, process, and technologies, the vision of future, the success criteria, and the early wins and the use cases. This is that first step to assess the current state of digital maturity. The second phase is defining the how and when. So that's crystallizing those outcome-based goals that are in alignment with both business and technical stakeholders. It has priority critical use cases. We identify and define the business and solution architecture, including those strategic partnerships in the ecosystem, the success conditions, the high priority tasks, implementation team, the ROI, as well as that roadmap to achieve that vision. And the third phase is executing and measuring for wins. And perhaps the most important area, because this is where we collaborate with customers to ensure that they are set up to succeed. We ensure that the systems are configured considering any technical dependencies and hurdles, and the customers have access to the solution. So they get quick wins around the identified most pressing problem areas, which were part of that first phase. And using the outcome of this engagement, the customers then successfully frame their challenge and focus their investments, mobilize, and then sustain that digital transition.
Can you talk about some of your key use cases and wins with some of the clients in these sectors?
Yes. So I've seen a wide spectrum of use cases that fall under the categories of asset performance management and operations optimization. Now, these use cases optimize the efficiencies and manage and maintain asset functionality, improve energy efficiency, and in some cases increases the knowledge through people interactions and integrate the OT systems with enterprise information systems. In the energy management space, we've seen use cases around using analytics to initiate HVAC and plug load controls based on occupancy density, which is where you're having real time monitoring and control so that you can optimize the performance of energy consuming equipment. In the healthcare sector, I've seen the use of sensor and geopositioning to manage the medical equipment and devices as a fleet and ensuring that the requirements of medical or surgical procedures are met in the most efficient and expeditious way. In the oil and gas sector, we've used the predictive analytics and simulation, which have been applied to drill head and the subsurface data to guide drilling based on identification of obstructions and any deviations from reservoir modeling expectations. For industrial manufacturing, the most important use cases in a factory setting have been around remote monitoring and predictive maintenance. But let me share a common theme emerging from these use cases using intelligent systems. So, elaborating on this industrial manufacturing example, I see that there are three main components: the industrial systems, such as robots, the machine manufacturer, who's the robotic OEM in this case, for example, and then the end customer, let's say it's an automotive manufacturer. So, the end customers and suppliers have been working on automation for some time now. They're now working on these smart factory initiatives, which can self optimize performance and self adapt to and learn from changing conditions in real time and autonomously run in a complete lights out mode. The use cases here are to automate transportation on factory floor by mobile robots, including those automated guided vehicles, or diversify factories and facilities by flexibly combining robots and equipment, and remotely monitoring and deploying robots in hard to reach places. Now, these use cases demand a transition from break fix product centric business models to predict and prevent services model, from big iron hardware to software defined machines, and all that with zero tolerance for jitter and delay. So the end customers want to use the data in near real time. They want to analyze, simulate the actions, close the loop by distributing optimized models to deployed industrial systems. So in this example, say the auto manufacturer needs time-sensitive production run with precision robotics in a factory. They use robotics for automation. They use real-time data to power decision-making. And they're acting based on sensory data and algorithms. They use a distributed computer across this continuum of edge to cloud. In the factory, let's say there are production challenges which get detected with robotics, and that affects the quality of a precision production line, which has time-sensitive delivery. Now, these challenges are captured through digital feedback loops, and they're fed back to the operations team. New simulations show a better way to program robotics at a key step in the production process to increase quality and operational efficiency. Knowledge of this is then shared across the team on a real-time collaborative workflow platform across geographies, and the new applications are recommended for increased performance. The tasks are adapted based on reprogramming through the cloud, and ultimately production processes become a bit more effective and efficient. The project comes in at target cost, the TQM targets are achieved, profitability improve. And what's interesting here and confirmed by our research that Forbes and Windover conducted is that the most successful intelligent systems companies focus on these digital feedback loops between company and the customer, which is OEM in this case, and they gain $4 back for every single dollar invested when compared to their peers. So I'm seeing this similar Teslafication kind of use cases across various sectors and subsegments. And what's happening based on what I'm seeing is that the ability for software to connect, manage, and extract data, that's becoming table stakes. Companies are finding out that updating their edge software will have a huge advantage over the competition. Amount of compute power needed to execute software commands at the point of control and manufacturing is growing exponentially. And it's, of course, coming in with much cheaper cost. So these industrial operators are building these intelligent systems quickly. They're placing workloads where they make the most sense for the business outcomes. And they're creating these evolved, flexible edge to cloud infrastructure, leveraging modern tools, technologies, and processes such as DevSecOps-based CI/CD, and they're thinking through the complete life cycle of development, deployment, operations, and services. And that needs a new way of performing continuous integration, and a complete intelligent systems lifecycle management platform is, of course, needed. So, amongst other factors, these are the use cases which are helping me guide Wind River's innovation and investment strategy.
I love the term Teslaification. I think you were the first to have used that on this podcast, and it makes a lot of sense. There are, of course, hard real-time deterministic controllers on factory floors, and they're usually called programmable controllers or PLCs. We've noted, though, with the semiconductor shortage that we've seen an acceleration of so-called software-defined automation, so substituting perhaps gateways and software for these traditional PLCs. The difference in some sense is we're seeing also a wave of distribution where this soft control can be distributed running containers or bare metal at the edge. Are you seeing the same as part of this Teslaification you referred to?
Yes. The software-defined and virtualized PLCs are real in my discussions as well. Although the semiconductor shortage has accelerated the adoption, I don't think it's new. Apart from other similar hardware-software abstraction use cases, this is kind of what led me to define and evangelize software-defined machines during my tenure at GE as well. The industry is taking steps towards a true hardware-agnostic, software-based PLC offering, and we see examples including Schneider Electric's EcoStructure Automation Expert platform, or Rockwell's latest emulation software for their control logics, or Siemens expanding its Edge offering with the introduction of the Industrial Edge version 1.0 platform. The why is really around the reduction of architectural complexity here. There's a lack of modularity within industrial automation software, which is driving higher design complexity, which in turn increases overall project effort. Within the software, there have been suboptimal architectural component boundaries, which can lead to increased interdependencies that multiply the number of components that the developers must modify when adding new functionalities. And these interdependencies also increase the time and expertise required to trace errors to specific software modules and development teams when a defect is detected. So to address these solutions, companies are drastically thinking about increased standardization and modularization, which can extend across platforms to keep their software complexity manageable. The OEMs are also focusing on decoupling this software from hardware and applying a service-oriented design. The hardware-software decoupling approach, it allows multiple entities to engage in modular development. And in turn, that modular software build-up techniques amplify code reuse, reduce the overall amount of code required, and minimize those security risks due to increased commonalities. Decoupling hardware from software further democratizes the hardware, which offers standard compute, memory, I/O, and power supply, while the software defines the end user functionality. So for applications requiring standard performance, different software functions can run on the same hardware using virtualization and containerization and be distributed dynamically to other hardware if necessary. For applications with real-time performance requirements, hardware-specific software development is still critical to achieve the optimal efficiency. Now, historically, at one end of the capability continuum, some embedded devices have performed fixed functions, they had long in-service deployment lifetimes, and they may have rarely undergone system upgrades that added new functionality or deployed security updates to address the latest security vulnerabilities. Systems without any network connectivity and running in air-gapped environments may have needed to be manually updated in the field, which is, of course, time-consuming, error-prone, expensive, depending on the number of devices deployed and the level of difficulty of the physical access to them. Processor performance has, of course, increased dramatically for many years now, and all these have accelerated innovation, enabling new application functionality to be deployed more rapidly to edge devices using secure communications. And these are driving those technical requirements for open standards-based software-defined architectures that can enable consolidation of multiple applications, including those at different levels of criticality, onto common compute platforms. And that approach enables that application migration, portability, and interoperability so that you get kind of avoid being locked into proprietary architectures. What we are seeing from the embedded space also is that although each vertical market faces unique challenges and requirements, there are a set of horizontal key requirements in this space. And that includes mixed criticality, which is a common requirement for a consolidated platform to host both the critical real time control applications and general purpose applications. You need to isolate safety components and reduce their dependencies on the rest of the platform in order to, let's say, ensure that the safety certification costs of the overall platform remain affordable. You need open standards and ecosystem, as I said. And there are several bodies, like in the industrial sector, the OPAF is focused on developing a secure, open standards-based interoperable process control architecture. The commercial aerospace sector has embraced the ARINC 653 standard. The US government has adopted the modular open systems approach. And the future airborne capability environment technical standard provides an open avionics architecture for military avionics. There are several other requirements like reuse and scalability, security, and of course, the support for modern development methods. So at Wind River, we do address these requirements through flexible virtualization platform that supports open standards-based software-defined architectures.
So in terms of kind of wrapping this down, given you've had a very broad and deep experience based, I'd really like to get a sense of your holistic perspective across cloud and edge, and probably more specifically, what would you predict for the next 5 years in terms of industrial intelligence systems?
So Wind River and Forbes Insights issued a new research that investigates the technological blueprint and a roadmap to success for a mission-critical intelligence systems world. Those details are at Wind River's site. 500 plus technology executives were surveyed across mission-critical industries, which includes industrial, medical, energy, aerospace and defense, etc. Now, here's what we found out for the manufacturing sector. The success in this intelligent systems future can be mapped out with 13 key intelligent systems characteristics, and applying the right timing to invest in these elements will determine the level of success. Only 11% of industrial manufacturing companies see themselves as already being intelligent systems digital business companies, and 55% of the remaining are actively in a strategic drive to get there. 66% believe that their embedded products and offerings need to be capable of computing in near latency-free real time for mission-critical success. So understanding what to invest in, when to invest in, and which economic and innovation-based outcomes you're looking to generate will define who wins in this machine economy going forward. Today, only 16% of organizations are building from the right blueprint, so the survey helps to learn from those. We understand that those sequencing the right investments in this space can attain results 4.5 times better than their peers. The most important shift for industrial manufacturing companies is moving more decision-making computing to the far edge, which is delivering compute on the far edge. You have to predict stresses, resolve failures, customize devices in the cloud. These are all foundational capabilities for success that must be delivered in a single real-time collaborative workflow. And these essential requirements dominate the focus of 70% of industrial and manufacturing leaders today. The longer-term 5-year vision is to build automated learning and machine learning capabilities. So the leaders are looking at a combination of cloud-based device customization, predictive systems management, and the sequencing of necessary workflow processes to create a clear path to practical success. And they're needing to focus on some of those core characteristics that will drive the success of later investments in AI, ML, and sensory data and algorithms. For example, some of them reported that the foundational capability of compute on the far edge is over 10 times more important than being able to run experiments as a learning system. Now, here's why this research matters. Most industries are heading towards this intelligent systems future. Intelligent systems approach is seen as being that predominant business model in the future for up to 1 in 3 companies. Winners are being determined right now. and there will be a blueprint for success. It'll be different for each industry with different key characteristics and an associated timeline for each.
Well, this has been such a deep and broad conversation. I hate bringing it to a close. Perhaps really one final question, which really gets down to your own inspiration, is what does inspire you? What are you reading or watching these days?
So, look, I read nonfiction physical books. The one I'm reading right now is The Trillion Dollar Coach, The Leadership Playbook of Silicon Valley's Bill Campbell by Eric Schmidt. I do listen to podcasts. So apart from Momenta's Digital Thread, which is a favorite, I do listen to Michael Gale's Future in Focus, Gartner Thinkcast, and Wall Street Journal's Future of Everything. And those are some of the things that I listen to.
Well, it's clear you're well-read, and at least we are well listened to, so thank you for that. So, Nikhil, thank you for sharing this time and insights with us today.
Thank you for this opportunity, Ken. I wish you and your listeners the best, and I look forward to keep learning from your valuable podcast.
Well, thank you so much. So this has been Nikhil Chauhan, Digital Transformation Officer of Wind River Systems. Thank you for listening, and please join us for the next episode of our Digital Thread podcast series. Thank you, and have a great day. You've been listening to the Momenta Digital Thread podcast series. We hope you've enjoyed the discussion, and as always, we welcome your comments and suggestions. Please check our website at momenta.one for archived versions of podcasts, as well as resources to help with your digital industry journey. Thank you for listening.